Yeah, hello, good afternoon, students. This is D. Narayana, Associate Professor in EC Department in our KG Reddy College of Engineering Technology. Now we are going to discuss about the problems on signal flow graph. In the previous topic, we have discussed about the basics of block diagram and concepts of the SFG. Now, in this class, we are going to discuss about SFG. SFG means signal flow graph. Here, signal flow graph is a alternate method to reduce the size of the system and to get the transfer function of any control system. Here, the scientist Masses has given one standard format to get the transfer function of any complex system. For example, if you take this problem, it is having G1, G2, G4, G6, G3, G5, H1, H2 and G7 as a transmittance of the signal flow graph. Using this signal flow graph, we need to get it's a transfer function by taking this Mason gain formula. Here the gain formula is T is equal to sum of k equal to 1 to n, I equal to 1 to n, pk delta k by delta. Here the k indicates the number of forward paths in the given transfer function given system. Pk is the meaning for the forward path gain of the kth forward for delta is equal to 1 minus sum of individual loop gains plus sum of possible combination of two non-touching loop gains plus sum of possible combination of three non-touching loop gains. So coming to this problem, here we are having four forward paths. Those are, first forward path is coming from RFS with the gains as G1, G2, G4, G6, 1 and 7. We are having this is a one forward path. Now we are taking its product of gains as P1 is equal to G1, G3, G4, G6, G7. Coming to we are having one more forward path, that is from RFS to G1. From there to straight away G3, G4, G6, G7 up to CS. So we are having its gain value as P2 is equal to G1, G3, G4, G6, G7. So coming to third one, we are having from starting RFS to G1, from to there G2. From that we have straight away to G5, G6, 1 and 7. We can take it as its gain as P3 is equal to G1, G2, G5, G6, G7. So similarly we are having the last forward path which is coming from RFS to G1, G1 to G3, G3 to G5. From there straight away we are having with G6, 1, G7. So we are taking P4 as G1, G2, G3, G5, G6, G7. So we are having number of k is equal to 4. Now we need to find how many individual loops are there. In this case we are having loops as this is one combination between the gains G6 and H1, G7 and H2, G1, G4, G6, G7 with H3. And last one is we are having G4, G6, G7 with H3 we are having. Another one is G3, G5, G6, G7 with H3. Last one is G2, G4, G6, 1, G7 and H3. These are the possible combination of individual loop gains. Okay. From the first loop we can write the gain as G6 with H1. For the second loop we are having gain as G7 with H2. Coming to this one G2, G4, G6, G7 with H3. Coming to fourth one G4, G3, G4, G6, G7, H3. Fourth, fifth one G3, G5, G6, G7, H3. Coming to sixth one G2, G4, G6, G7 and H3. So these are the loop gains of the given system. Now we need to find non-touching loop combinations. Here we are having non-touching loops as G6H1 and G7H2. These two are the possible combination of non-touching loops. Now we need to find their determinants also. So here we are taking non-touching loops as L12. So L12 means combination of G6 with H1, G7 with H2. Now we need to find the determinants of four paths. Those are delta 1, delta 2, delta 3 and delta 4. So delta 1 means 1 minus sum of individual loop gains plus sum of possible combination of two non-touching loops plus sum of possible combination of three non-touching loops. So from that we need to get delta 1. So according to that we are having 1 minus 0 is equal to 1 here. So for the second path also we are getting same 1. For third also we are getting same 1. For fourth also we are getting only 1. So there is no individual loops and possible combination of any two non-touching and three non-touching loops, so that we are having only delta 1 as 1, delta 2 as 1, delta 3 as 1, delta 4 as 1. Now we need to find the overall transfer function of a given system. That is equal to p1 delta 1 plus p2 delta 2 plus p3 delta 3 plus p4 delta 4 by the determinant of the whole system. Here we are having an equivalent for p1 delta 1 as L1, p2 1 minus of, here we need to find the delta value is equal to 1 minus of individual loop gains plus sum of uh, gain of a possible combination of non-touching loops L12. From that we are finding 1 minus of L1 means G6H1 G1 G7H2 G2 G4 G6 G7 H3 plus G4 G6 G7 H3 plus G3 G5 G6 G7 H3 plus G2 G4 G6 G7 G5 H3 and so on, uh, plus non-touching loops. We are having here only one possible combination of two non-touching loops G6H1 G7H2. Now what is the meaning for individual loop? Any guys? Yeah, let me explain. The individual loop means the loop has start and end at common node, same node. What is meant by possible combination of two non-touching loops? It means the two individual loops cannot be shared by same node. Okay, na? Now we need to find the overall gain of the system. So transfer function is equal to G1, G2, G4, G6, G7 into 1 plus G1, G3, G4, G6, G7 into 1 plus G1, G3, G5, G6, G7 into 1 whole by 1 minus of G6A1 minus G7 H2 minus G2 G4 G6 G7 H3 minus G3 G4 G6 G7 into H3 minus G3 G5 G6 G7 into H3 minus G2 G4 G6 G7 G5 into H3 plus G6 G7 H1. So this is the simplest way to get the transfer function of the whole system. Okay, na? So you need to have much practice on these problems on SFG concept. Thank you.